Okay, so it's Wednesday, so PS1 is due tomorrow, in theory, but in practice, like everything else, first 2 weeks, you're going to have until September 3rd. Any questions or problems about anything? Okay, a couple things I want to point out. You can miss up to 3 labs and still get 100% credit for lab participation. Okay? And I put that in place to avoid having 350 people asking me for to be excused from labs every now and then. I just leave it to you. You can pick 3 and skip if you want to. You don't have to ask me about it. You just don't show up. And for the assignments, for the problem sets, you can, they're due on Thursdays, but you can hand some number in late without a problem. You get 1 extra day on some number, which I can't remember right now. Does anyone remember what number I put in the syllabus? Well, I'll direct you to the syllabus. It says how many times you can have a free late day for your assignment. And again, that's just, you use it when you need to use it. Okay. In the lab yesterday, you worked with static methods. In lecture last time, we talked about static methods, and we're going to talk some more today about them. These are some more of the slides that I skipped over last time, so I thought I'd use them here just to remind you what we were talking about. So the Java library provides lots of static methods. This is an example here of one such method. And if you go look at the documentation, you'll see that its name is max. It takes 2 parameters, and it returns the larger of the 2. So that's pretty typical of Java documentation. There's a link on the Canvas page where you can go to the full Java documentation of the entire library, browse through it if you want to. This is also what pops up when you hover the mouse over max when you use it in a program. Right, so that's a static method. Here's a static method from the library I gave you. That you're using for PS1, show message dialog. And it brings up a dialog, displays a message. Now, I'll let you in a little secret. You may wonder how we test your program inside of Gradescope, because you submit your program to Gradescope and it runs some tests. The problem is that your program, when it runs, it pops up these windows that you have to type into. And when it's done running, it pops up a window, and you've got to look in what's in it to figure out what it says. The way we test your program is you hand in your code. I don't use the library I gave you. I substitute a different implementation of the library that provides the same methods, and so your program will compile against it. But they're re-implemented not to use any GUI at all. It's, no graphical user interface at all. It's re-implemented so we can run tests against it. So that's one advantage of programming to a specification. You don't need to know what's going on inside the library. You just need to use it. And then when you do that, I can throw away one implementation, use a different one, and it won't affect your program at all as far as testing it goes. That's why some of you didn't read the directions very carefully, have been using other ways to get dialog boxes to pop up, such as JOptionPane show message dialog. JOptionPane is a Java class that provides a method. If you do that, you won't pass any tests at all, because you need to be using my library. So when you look at the documentation, this is what you're looking for. You can see this is a static method because it says static. And again, we'll talk later today about what it means for a method not to be static, but for now it's the only kind we've seen. It has a name that you see there. It has a list of parameters that it takes. Now, this list of parameters, it says one is A and one is B. Is that important to you? Do you need to know the names of the parameters that max takes? You need to know the number. It takes 2. You need to know what type. They're both ints. What about the A and the B part? Do you need to know that in order to make use of the method? Okay, what do you think? No. It doesn't matter to you at all when you're using the method. It does matter, though. Why do they put it there if it doesn't matter? Why don't they just say int, comma, int? Why do they say int A, int B if the A and the B don't matter? Yeah? Well, they have to use it in the method implementation, sure, but they don't have to show it here. So you might wonder, why do they, the documentation that's generated, why does it leave the A and the B in if they don't matter? Yeah?
It's maybe easier for the programmers to read?
Well, it may be easier for programmers to read. It's really, that's sort of it. It makes it possible to read the documentation. Now, in this case, it doesn't say much about A and B. It just says A is an argument, B is another argument. That's lazy documentation. Typically, if you read the documentation, it'll refer back to A and B. So it just provides a way for the person that wrote the comment to refer to the parameters. But other than that, it doesn't matter when you use the code, when you use the method. There's the return type, which comes before the name of the method. That's what type of thing the method produces. And what was the return type of the methods you used in the lab yesterday? Yeah? Void. So void methods are ones that don't return anything. When they're done, but they don't compute and return a value. Instead, they do something else. They cause some side effect. And what was the side effect of those methods called yesterday? What was the point of calling them? Yeah?
They printed things to the console.
Right, they printed things to the console. So you call it to make things be printed to the console. You're not calling it to get some value back. And then you get the behavior in the java.comment. That's java.comment in the code for the library. So you learn to read the documentation to get out what you need to know. Okay? So here's another method, and this is from my library. I wrote the documentation. And you can see it's got the same thing: static, name, parameters. In this case, no return value because it's void, and behavior. And you can see that under parameters, it says MSG is message to display, and you look up in the header and you see it, it refers back to MSG. That's what I was talking about. Okay, so that's the deal with static methods. There are lots of them, and you can create your own. And for the next little while, that's what we're going to do. We're going to create our own static methods, get some experience doing that. Okay, back where we were working on this static demo class, and we implemented getBMI, and then we implemented isTeenager. And then I had a little trouble with JShell. I realized right after class what I have done. You have to right-click on the correct project for it to work. I right-clicked on this project here, which is the first day of class. So this is the project that contains isTeenager. And so I'm going to click there and do launch JShell. And there we go. So now when we're in JShell, the class is called static demo, so I can say static demo dot isTeenager 18, and it tells us true. I can do 3, it'll say false. I can do 33, it'll say false. So JShell gives us a quick way to test out these methods. So you write a method, you don't have to create a main method then to call it and display the answer. You just play around with it in JShell like this. Now, I know from experience that many of you are probably still mystified about how isTeenager works. And so I want to spend a little bit more time on that. I want you to, fundamentally, it's simple. You call isTeenager, you give it a parameter age, it evaluates that expression I've highlighted, and that's either going to be true or false, and it returns it. And as I observed last time, what makes students uneasy with this sometimes is you're just not used to that operator double ampersand. You're not used to that AND operator. You're not used to writing expressions that are computing trues and falses. You're used to math class, you're really, all the time, you're writing expressions in math class that compute numbers or compute functions in the case of calculus. But Boolean valued expressions are a little more rare. Just takes some getting used to. So let's try some experiments down here in JShell. So I'm going to start, I'm just going to I'm going to say int age equals 17. Okay, so I've got age set. Now, let's try this expression right here. Age greater than or equal to 13. Okay? What's the value of that expression? Okay, first of all, how do you know the answer has to be true or false? It's not going to be 15 or some string. How do you know the answer has to be a Boolean? That the type of that expression is a Boolean? Yeah?
The operator.
Right, the operator, the greater than or equal to operator, it compares two integers, or two numbers, really, and produces either true or false. So we're not asserting that age is greater or equal to 13. We're testing whether it's greater or equal to 13. So I ask JShell or Java to evaluate this expression. It's going to say that's true. Now, what if I also ask, is age less than or equal to 19? Is age less than or equal to 19? Yeah. That's true as well. So what if I ask, are both of those things true? Is it simultaneously true that age is greater or equal to 13 and age is less than or equal to 19? Okay? We know that the first thing here, we know that this sub-expression is true. We know that this sub-expression is true. And so the AND operator combines true and produces what? True. So if the two operands to AND are both true, then the result of the overall expression is true. Otherwise, it's false. So we do that and we calculate true. Okay? So what would happen if I changed age? Say I make age be 10. So I've changed age to be 10. Is that true or false now? Age greater or equal to 13? That's false. I'm just using the up arrow here if you're wondering. Okay? What about age less than or equal to 19? That's still true. What's going to happen when I say, are both of those things true? False. They're not both true. One's true and one's false. And so we get false. Similarly, if I set age to 60, I'd get false for a different reason. If I changed it to 60, age would be greater than or equal to 13, but age would not be less than or equal to 19. So I change age to 60, rerun this, it's going to say false, not a teenager. Okay. So when this method age is called, what happens is, whatever parameter, when you call it, so if I say, static demo.isTeenager, 26 divided by 2. Okay? What are the steps that Java goes through when it tries to evaluate the isTeenager of 26 divided by 2? What does it do first? Right. It evaluates the first thing Java has to do is evaluate the parameters that you're passing to the method. So that can be any expression whose value is an int. And so it divides 26 by 2 and gets 13. Then it passes 13 as the parameter to isTeenager. So what happens in isTeenager? When this statement is executed in isTeenager, what's the value of age going to be? 13, so it'll do that and return true. On the other hand, if we ask isTeenager of 120 divided by 2, then in that call, age would be 60, and this would be false. So it's just, each time you call isTeenager, age can have a different value. It just depends on how it was used, how it was called. Right? So that's a method. We're going to look at some more methods. Any questions I could answer about this one before we look at more? Okay, I'll tell you, PS2 will consist of a list of static methods for you to implement. So it's something you need to get good at. I know in class a lot of times it's tempting to, if you don't understand, to tell yourself, I'll figure it out later. It's best to figure it out now because we build on things. I often make the analogy that you can't treat this class like you might treat a history class. And this is what I mean. Suppose you're taking a history class and you miss the lecture on the Civil War. You'll still be okay when the test asks about World War II. Probably. They're sort of, independent in some way. But here, if you decide that, I don't understand static methods, I'm just going to skip that mentally and figure out the rest of the course. You can't do that. Everything builds on everything else. So you've got to understand as we go. You don't get behind. And so your goal in lecture here ought to be to understand it fully. Any question you have, I bet half the class has. So that's just my way of trying to encourage you to ask questions. Right? Here's one. Average. I want a method that takes in 3 doubles and returns their average. So I'd like to be able to call it like, down here, I'd like to be able to say, let's take the average of 3.1, 2.9, and 4.5. I'd like to be able to do that. Right now it won't do it because it doesn't know that method. I'm going to have one. Question?
I'm just a little confused on what static method actually means and what the alternatives to that one.
Okay, so let's start. There's 2 words there, static method. Okay, let's think about method first. So a method is like a function in mathematics. It has a name, it takes some parameters, some information, and it computes some kind of result and returns it. That's method. So think of that as a synonym for a function. Some languages, methods are called functions. Static, we'll look at, some methods are static and some aren't. But it's pointless trying to describe the difference until I got something to compare it to. So later today, we'll look at non-static methods. But for now, just think, okay, static is just always there. Anything else? Okay, I want an average method. So I'd like you all to make it so. Take a couple minutes, talk to the people around you, see if you can write one on paper for me. Okay? You'll eventually be doing this on the midterm. If you got your laptop, you can use it. Okay. Who could tell me how to do this? How do I create a static method called double? Yeah?
Start with public static int, public space.
Okay. You say public static. Yeah, we just got to do that because I said so. Okay, what comes next is the return type.
Int.
Okay? I got to disagree with you there because we're working with doubles, right? So the return type is double. And then what?
Average.
I told you the name of the method is average, so that's good.
Parentheses.
Okay.
Int.
Well, double.
Double. Num1.
Okay. So let's talk about that. For is teenager, I called the parameter age, which makes sense. So you always want to use variables that suggest what the value means. So typically, I would say a variable like num1 isn't very descriptive. But in this case, it's about as descriptive as you can get, right? I mean, what can you say about the numbers that you're averaging except that they're numbers? Okay? So I could use X, Y, and Z or whatever, but I'll go with you. Num1, num2. Okay, and then rather than finish this, I'm just going to make it return 0 just to get a stub down. So it's nice to be able to look at it and see that there's no red, that you've got at least got the header declared right. Okay? Now, before we implement it, what should we do before we actually write any code in the body? What was that? Document it, right. Now, how do I do that with Eclipse's help? /*, return. And I'll just say returns average of num1, num2, and num3. I've really got nothing more to say. In this case, I have nothing to say about anything about those parameters, what they mean. I mean, they're just numbers. Okay, so we've got that written. And then someone else tell me, what do I return from inside the method? What's the expression that I want to whose value I want to return? Yeah.
Open parentheses, num1 plus num2 plus num3 close parentheses divided by 3.0.
You could do divided by 3.0. If you put divided by 3, it'd be okay. And because in Java, if you mix integers and doubles, if you like add an integer to a double, it'll automatically turn the int into a double before it adds them. But at 3.0 is fine. Okay, so that's a pretty easy method to write. Now, to try it out, I'd come down here. It still doesn't know what average is because what I have to do is, if I remember this right, is reload. Okay, so that it basically starts up JShell again, replays everything it did before. And then I've got average, so I can try that out. 3.5. Is that right? It's easy to be mesmerized by the result and say that looks right, and I think it is right. But a good test case is one where you know the answer you're expecting. And so a better test case would be something where I actually know the answer. So that's average 3, 5, and 4, and I'd expect to get 4 out. And that would give me more confidence now that it really does say 4. Okay, so there's a method. Pretty straightforward. Let's write another one. I'm going to write the header for you this time. It's going to be is lowercase letter. What's going to take as a char, a character as a parameter, and it's going to return true if it's lowercase letter A through Z and false if it's any other kind of character. Now, it turns out there is a static method in the character class. There's a character class in Java that has a static method that'll do this, but let's just do it ourselves. So, okay, so public static, for whatever reason, what's going to be returned by this method? No, it's not computing a char. Boolean. It's telling us whether or not the char that comes in is true or false. Is it a lowercase letter or not? And I told you to call it is lowercase letter. And we got to take a character in. And again, it's any old character, so I'm just going to call it C. You've got to be, and I want you to understand that the reason I call it C is because it has no property other than the fact that it's a character. If it was like someone's initial, I'd call it initial. If it was, male or female or whatever, I might say gender. If it has some, or M or F, okay? If it has some meaning, I use it. And I'm just going to say reports. I like to say, I deleted too much stuff there. Reports whether C is a lowercase letter in the Latin alphabet. Because I don't want to know if it's a lowercase Greek letter. I want to know if it's a lowercase letter in the alphabet that I'm using right now, Latin alphabet. Okay. Well, how do you compute that? How do you compute whether or not C is a lowercase letter? What's that? Say it one more time, a little louder.
ASCII value.
He said ASCII value. And so, yeah, you could go look in a book and find out the ASCII values, the integer codes that are used to stand for characters, but we can do a little better, yeah.
You could use like a char method to like turn it lowercase and see if it's equal to the original value.
Yeah, there is a character, it's a got a char is the primitive type. The class is called character with a capital C that has static methods, and there is one that'll turn it to lowercase, but I also want to know if it's in the Latin alphabet, and that wouldn't. You could have a lowercase Greek letter, yeah?
You make a variable or a string that stores all lowercase letters,
Mhm.
and you check if the input is in that string.
Okay, so that would work if we knew how to use any string methods, which we haven't talked about yet. Okay, yeah?
Just use the range for the Unicode.
Okay, so it turns out, he used the word Unicode. Every character that you can use in Java can be has a Unicode value. It's a 2-byte, 16-bit standard, and so every letter, every character has a different integer that stands for it. And it turns out that A through Z are all in a row. So A has some value, and B is one bigger, and C is one bigger, and D is one bigger. It turns out you can do this. I didn't expect you to know this. Okay, and you can compare characters to each other, determine which comes earlier in Unicode. And it turns out that, talking about lowercase letters, Unicode order is the same as alphabetical order. So we're just asking, is the character C, is its Unicode value greater or equal to A's Unicode character, and is its Unicode value less than or equal to Z's Unicode value? Okay, so that's just it looks a lot like is teenager now. We're just asking, does C occur in this range somewhere, instead of asking, does age occur in a range somewhere? Now, what if you want to know if they were uppercase letters? Right, we just use capital A and capital Z. What if we want to know whether they were either lowercase a through Z or uppercase a through Z? Yeah, it turns out that I think first you get, I can't remember exactly, maybe the lowercase letters come, and then there's some other characters, and then the uppercase letters, or vice versa. So there's no single range. You'd have to write a more complicated expression involving ands and ors. I don't want to do that right now. I just wanted to show you this because a lot of students tend to forget that you can directly compare characters like this. And it's a good thing you can compare characters because a lot of times computer programs want to put things in alphabetical order. And you do that by essentially comparing characters. If you couldn't compare characters, it'd be tough to sort things into alphabetical order. Okay, so there's a method. We did that one. And we did average. I'm going to do one more before we move on to something else. Okay, so you pass in n, and you get out the sum of the first n integers. So a lot of times it's helpful to put examples. So let's do that. What if I ask sum to n of 3? What should that be? That's 0 plus 1 plus 2 plus 3. You go up to the 3 if we pass in 3, so that would be 6. What would sum of 1 be? Okay, that's 1. Yeah, and then people are always going to ask this: what is sum to n of 0? So that's the sum of the first 0 integers, and we could argue about what it means. I'm just going to assert that means it's 0. Okay, so hopefully you got the idea here. How do we implement that? Yeah.
You could use a for loop or a recursion.
Okay, he suggested using a for loop or recursion, neither of which we've talked about yet. So let me rephrase the question. How could you do it given what we know so far? Yeah? Okay, you can use math. So there's an old story about a mathematician. Who was a mathematician? I don't know if it was Euler or it was, anyway, who discovered this formula when he was very young. But basically, let's think about if we add the numbers from 1 to 100. One way to do that is to say, okay, let's pair up the 1 and the 100. That's 101, right? What's 2 plus 99? 3 plus 98. 4 plus 97. And you go all the way to 50 plus 51. So we've got 50 pairs of numbers, each of which adds up to 101. So what is the sum of the numbers from 1 to 100?
101 times 50.
Yeah, 101 times 50. So it's 5,050. So the formula is the sum of the first n integers is n times n plus 1 divided by 2. Okay? So I'm doing this. Let's make sure it works here before I say why I'm doing it. It's n times n plus 1 divided by 2. So let's go down here and reload. And let's get static demo dot sum to n of 100 and make sure we get 5,050. Okay. So it's you know a programming language, and you know how to we'll eventually learn how to use loops, as he was suggesting. And suddenly, once you know how to make a loop, is a way you get things to repeat in the program. So if you want to add it up, if you want to physically add up the numbers 1 plus 2 plus 3 plus 4 plus 5 and so on, you'd use a loop. And once you know how to use loop, every problem looks like a loop. But if I were to do this, if I do it this way, I get 5,050. If I wrote it a different way and had it actually do all those additions, I would get the same answer. Which is better? Which way of doing it is better? Yeah, that is. Okay? Because if I want to know what's the sum of the numbers from 1 to 1,000, no matter how big I get, I'm doing a multiplication, an addition, and a division. Whereas if I did it with a loop, I'd be doing like 1,000 additions. And the bigger that number gets, the slower this becomes. The slower the doing things repeatedly becomes, whereas this one stays just as fast. So it's not enough to know how to program. You got to know some math in this case. You've got to know the domain you're working in. Okay, so we have implemented a few methods. I'll leave those unimplemented. Let me see if there are any questions now. See, I'm going to be giving you on PS2 some methods to implement. None of them will require loops. None of them will require if statements, because we haven't talked about loops or if statements left.